You think gravity is powerful. You look at the universe and you see it holding planets in orbit. You see it crushing stars into black holes. You feel it right now, anchoring your feet to the floor. It feels like the dominant, crushing force of reality. But that sensation is an illusion caused by scale. The truth is, gravity is pitifully weak. In fact, it is the weakling of the physical forces, a ghost compared to the true monsters of physics. Don't believe me? I can defeat the entire gravitational pull of planet Earth with a tiny piece of metal I bought at a gift shop. In this video, we are going to explore the hierarchy problem, the single biggest mystery that keeps physicists awake at night. We will ask, why is gravity so pathetic compared to the other forces? We are going to calculate the terrifying difference in strength between the static shock on your finger and the gravity of a star. And the answer? The answer might imply that gravity isn't actually fully here. It might be leaking into hidden dimensions you can't see. By the end, you will understand why the universe is balanced on a knife edge of weakness, and why, if gravity were even slightly stronger, you wouldn't exist. Gravity feels strong. When you trip and fall, you hit the ground with force. When you pick up a heavy box, your muscles strain against the pull of the earth. You spend your entire life fighting this force. It feels like the antagonist of your existence. But you are being tricked. You are suffering from an illusion of scale. You feel heavy, not because gravity is a strong force, but because you are interacting with a monster. Think about what is pulling you down. It isn't just the floor. It isn't just the bedrock beneath the building. It is 6 septillion kilograms of rock, iron, and molten metal. It is the accumulated pull of every single atom from here to the core of the planet, 4,000 miles down. It takes the entire Earth, every mountain, every ocean, every continent, pooling its collective effort just to keep your feet on the ground. And yet, I can lift my hand. I just defeated the Earth. The entire planet is pulling down on my arm, and with a tiny chemical reaction in my shoulder muscle, a little bit of electromagnetic energy, I won. Gravity is not a bully. It is a whisper that only sounds like a scream because there is so much of it. Let me prove this to you with an experiment you can do right now. Here is a paperclip. Gravity is pulling it down. The entire mass of the Earth is reaching up with invisible hands, desperate to keep this piece of metal on the table. The Earth has a 4,000-mile head start. Now look at this, a tiny magnet, a piece of iron the size of a coin. It has almost no mass. Watch, snap. Think about the violence of that uneven fight. That tiny magnet just outmuscled an entire planet. The electromagnetic force inside that little disk is so exponentially stronger than the gravitational force of the Earth that the Earth didn't even stand a chance. This isn't a fair fight. It's not even a contest. If gravity were a person, it wouldn't even be strong enough to lift a single skin cell off your body. The only reason you care about gravity at all is that you happen to live on a sphere of iron that is 8,000 miles wide. So how weak is it? We need to put a number on this or your brain will try to ignore it. In physics, we have 4 fundamental forces. 1, the strong nuclear force. 2, the electromagnetism. 3, the weak nuclear force. 4, gravity. Let's compare gravity to electromagnetism. Imagine you take 2 electrons, just 2 tiny particles. They have mass, so gravity pulls them together. They have charge, so electromagnetism pushes them apart. Which force wins? The electromagnetic repulsion is not double the strength of gravity. It is not 1,000,000 times stronger. It is 1036 times stronger. That is a 1 followed by 36 zeros. To give you an idea of how absurd that number is, if you expanded a single virus to the size of the entire observable universe, that is roughly a factor of 1036. That is the difference in strength. Gravity is effectively 0. In the quantum world, when physicists write equations to describe how atoms behave, we don't even include gravity. We set it to 0. It is so pathetic that it literally doesn't matter. This explains why the universe looks the way it does. Look at an atom. You have a positive nucleus and a negative electron. They are attracted by electromagnetism. If gravity were the only force, the electron would simply drift away. The gravitational pull of the proton is too weak to hold in orbit. But wait, why doesn't the nucleus fly apart? You have protons packed in there. Positive repels positive. The electromagnetic force is trying to blow the nucleus apart with massive violence. Gravity can't stop it. Gravity is 1036 times too weak to hold the nucleus together. So nature had to invent a monster, the strong nuclear force. This force is 100 times stronger than electromagnetism. It is the glue that overpowers the electric repulsion and clamps the protons together. So you have this hierarchy. The strong force is the king. Electromagnetism is the queen. Gravity is a dust mite. But pause. Something should be bothering you. If gravity is the dust mite, if it's a ghost, if a fridge magnet can beat a planet, why is it the only force you notice? Why does gravity orchestrate the galaxy? Why does it orbit the planets? Why is it the dominant sculptor of the cosmos? The electromagnetic force is trillions of times stronger, yet the Earth isn't being pushed around by magnetic fields from the sun. It's being pulled by gravity. Why does the weakling run the show? The answer: because gravity has no opposite. Electromagnetism has a plus and a minus, positive and negative. And in the universe, they love to cancel each other out. Every positive proton in the Earth has a negative electron nearby. The net result? Zero. The enormous, terrified power of the electromagnetic force is locked up, canceling itself out perfectly. The Earth is electrically neutral. But gravity? Gravity has no negative. There is no anti-mass that pushes away. Gravity only attracts, so it stacks. One atom, nothing. A bucket of sand, nothing. A mountain, now you feel it. A planet, now it dominates. Gravity wins not because it is strong, but because it is persistent. It is the only force that builds up without limit. Now we arrive at the mystery, the deep rot at the center of modern physics. Physicists hate coincidences. If we find a number in nature, we want to know why it is that number. Why is gravity 1036 times weaker? Why not 1010? Why not equal? This gap is called the hierarchy problem. According to our best mathematics, the mass of the Higgs boson, which gives particles their mass, should be huge. It should be heavy, but it isn't. It's light. And because particles are light, gravity is weak. The math suggests that there should be huge quantum corrections that make gravity just as strong as the other forces. But something is canceling those corrections out. To get the universe we see, the numbers have to be fine-tuned to dozens of decimal places. It's like throwing a dart from the moon and hitting a specific bullseye on Earth. It looks artificial. It looks wrong, unless we are missing part of the picture. What if gravity isn't actually weak? Imagine you're an ant living on a flat sheet of paper. You can only walk forward, backward, left, and right. You have no concept of up or down. Now imagine that sound waves are trapped on that paper. They can only travel along the sheet. They are loud, strong, but imagine that heat is different. Imagine heat can drift off the paper into the air around it. To you, the ant, heat would seem incredibly weak. Why? Because it's leaking away. It's spreading out into a dimension you can't see. This is string theory. Some physicists propose that electromagnetism, the strong force and the weak force, are stuck to our 3D universe. They are trapped on the brain like the ant. They stay concentrated. But gravity? Gravity might be a closed loop of string. It might be able to drift off the brain. It might be leaking into a fourth, fifth, or sixth spatial dimension. If this is true, gravity is actually just as strong as the other forces. But by the time we feel it, it has diluted itself by spreading out into the bulk of a higher dimensional reality. We are only feeling the tiny fraction of gravity that's stuck around in our universe. This sounds like science fiction, but we are actually testing this. If gravity leaks, then at very, very tiny distances, it should suddenly get strong. We are smashing particles at the Large Hadron Collider right now, looking for mini black holes that would appear if gravity suddenly became strong at the microscopic scale. So if gravity is a leaking ghost, how can it create the most violent objects in the universe? A black hole, the ultimate victory of gravity. You might think, oh, a black hole must have incredible mass. Actually, no. You can have a black hole with the mass of the Earth if you squeeze it hard enough. Gravity wins in a black hole not because it becomes stronger, but because the other forces give up. Remember the electrons repelling each other in your hand? That's what keeps the Earth from collapsing. It's called electron degeneracy pressure. But if you pile enough mass on top, if you stack the gravity high enough, it eventually overcomes that pressure. It crushes the electrons into the protons. Then you have a neutron star. The strong nuclear force fights back. It says stop. But if you add even more mass, gravity breaks that too. Once you cross that line, there is no force in the known universe that can push back. Gravity, the weakling, wins by attrition. It collapses space itself. A black hole is what happens when the weakest force in the universe finally gathers enough allies to break the laws of physics. Why does this matter to you? Okay, gravity is weak. Cool math trick. No, it is the only reason you are alive. Stars are fusion reactors. They burn because gravity tries to crush them, and the nuclear fire pushes back. It is a delicate balance. If gravity were a little bit stronger, let's say 1030 times weaker instead of 1036, stars would not last billions of years. They would burn through their fuel in a few million years. They would crush themselves instantly. Evolution took 4 billion years to make you. If gravity were stronger, the sun would have burned out before bacteria even evolved. The universe would be a graveyard of black holes and neutron stars. If gravity were weaker, stars and galaxies would never form. The gas would just float there, cold and dark. You live in the Goldilocks universe, the universe where gravity is pathetic enough to allow stars to burn slowly, gently, for billions of years, giving life a chance to wake up. So the next time you drop your keys and you get annoyed, or you look at a wrinkle and blame gravity for sagging skin, remember the magnet. Remember that you are fighting a force so weak it might be leaking into another dimension. Remember that your body is held together by the electric force, a titan that dwarfs gravity by an incomprehensible magnitude. To help you visualize this, I've created a hierarchy of reality concept map. It breaks down the 4 forces, their ranges, and the specific domains where they win. It's a great way to reorient your brain when you look at the world. You can get it for free by joining the physics newsletter below. Gravity is weak, but it is patient, and in the long run, patience wins. If you want to understand the monster that gravity fights against, the electromagnetic force that prevents you from falling through your chair, hit subscribe. We're going to break down the illusion of touch next. And don't forget to grab the Forces of Nature concept map in the description. It's a PDF guide that scales the universe from the quark to the quasar. Click the link to join the waitlist and get it sent to your inbox.